So now we're going to talk about assumptions when we do linear regression. So testing the significance of the correlation coefficient, you have to have certain assumptions that you reach. You do this with any kind of inferential statistics that you run. But for regression, this is what you need to look at. Since we can't look at that entire population, we need to think more about that sample we're looking at it. Because again, what we're trying to do is see if there's a linear relationship between X and Y so that we can predict based on that. So the regression line we can calculate from the sample data that gives us that line of best fit. So when you examine the scatter plot and you test the significance, you need to see if it's appropriate. So the first thing that you need to do is there a linear relationship for the population? So that means is the expected value of y in a straight line for the population. Again, it doesn't have to lie on the line, but it has to be near the line. So the values for any x need to be normally distributed. So think of that bell-shaped curve. If you go on for more statistics classes, there's different normality tests you can run. There's something called the Anderson-Darling test. There's a bunch of other ones that tell you without having to look at the data if it's normal or not. While you don't have to, I would always look at your data just to visually get an idea of what you're doing. So the standard deviations of the population Y values are equal to the values of X. So basically, again, you have to have a normal distribution for the Y and the X. The residual errors are mutually independent. And it's really important when you do multiple regression to look at the residuals and see if they're all randomized. If they're not, then something's going on, and most of the time you cannot run a linear regression. So here's an example of normal distributed data. So here you can see in the first graph, the dots in the middle are close to each other and then they spread out. It's basically what you see in the right. That's what's being said when we say normally distributed data. Because remember, 68% of that data is one standard deviation from the mean, which means one standard deviation below and one standard deviation above.